So now this video discusses about what we call as the types of matrices. So matrices are categorized into two or more actually types, and they're basically based on the number of rows in the number of columns, and also based on the orientation of the members, and also the components of the members as well. So let's see how we can have these types of matrices. So the first one, we have it as the row matrices. We have what we call as the row matrices. We have what we call as the row matrices. So what are the row matrices? Now, row matrices, these are the matrices with the actually number of rows given as one. In other words, row matrices follows the order of, should be 1 by m matrices, should be 1 by m order, of which m can be any actually number apart from 0 or negative. So which means we can have, let's say, 1 by 5 matrices, we can have that matrix. We can have, let's say, 1 by 6 matrix, actually matrix, 1 by 2 matrix. In other words, the row matrices, these are the matrices with these are the matrices with the number of rows as one. You can have, let's say, 2, 5. Let me have this. You can have, let's say, 2, 5, 7. This is a typical actually row matrices. This is the typical row matrix you should have to understand. Let's say we have A, you can have, let's say, A, B, let's say C. This is actually a row matrix. In this case, we have it as 1 by, should be 1 by a 3, and 1 by, let's say, 3. We can also have, let's say, 1 by 5, and try to have 1 by 5, 1 by 7, and 1 by 8, and also 1 by 6. So try to have that. So basically, row matrices contains the number of rows as 1. And we also have what we call as the column matrices. So column matrices. So for this case, it is the opposite of the row matrices. So in this case, the matrices are of actually columns as 1. So in this case, they follow the order of n by 1. So in this case, we can have 2 by 1, we can have 3 by 1, it can be that. And the basic examples we can have, we have it as, let's say, 5, 4, 2. This is basic actually column matrices. That is, we have 3 by 1, because the number of rows, actually the number of columns is basically 1. So which means, and for the column matrices, you should have to get it that the number of columns is basically 1. So that's how you should have to understand about the column matrices. And we also have what we call as the square matrices. So on the square matrices, the number of columns and the number of rows are the same. There should be the number of columns and also the number of rows are the same. So in that case, which means we can have, let's say, 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix. These are the basic actually square matrix, and basically they possess the shape of the square. So that's why we have it as the square matrix. Let's say we have 2, 5, 0, 5. So this is a typical actually square matrix, and since the number of rows and the columns are the same, and let's say we can have, let's say, 0, 2, 0, 6, 1, 0, 7, 0, 5. So this is also part of the square matrix, and from the fact that the number of the columns and also the rows are the same. So try to have, let's say, a 6 by 6 matrix, and also, let's say, 4 by 4 matrix. It also should be 3 by 3 matrix, and you should be well conversant with those. And we also have what we call as the rectangular matrices. We have what we call as the rectangular matrices. So now on the rectangular matrices, in this case, there is a difference in the number of rows as well as the columns. In other words, M is not the same as the N. So we can have, let's say, 2 by 5 matrices, and provided the M is not the same as the N. So that's when we have actually the rectangular matrices. We can have, let's say 2 by 4 matrices, and that is, we can have, let's say 1 by, let's say, and there should be, we're going to have, let's say 5 by 2 matrices. That is a typical example of the rectangular matrices, and provided the number of the columns and the rows are different, that's when we have the rectangular matrices. And now we have another type of the matrices. And what is that? We have what we call as the zero matrices. So what is the zero? What are the zero matrices? On the zero matrices, all elements are given as zeros. So zero matrices, all components are zeros. You can have 0, 0, 0, 0. So this is a typical actually zero matrices. Zero matrix. All the members must be zeros. So that is actually zero matrix. So no matter the orientation of the order, but much as they are all zeros, that is a zero matrix. And finally we have it as what we call it as the identity matrices. So what are the identity matrices? Now on the identity matrices, the members has to be zeros and has to be ones. So that is about the identity matrices. And the orientation matters. On the identity matrices, by the way, the symbol for the identity matrices is given as capital I. That's the symbol for identity matrices. Wherever you see this, just have to know that it is the symbol for the identity matrices, and that is being used in the case of the matrices. So on the identity matrices, I'm saying these are the matrices where the members only zeros and 1. But now orientation matters. Now in this case, on the actually identity matrices, the ones must be diagonally presented. You can have, let's say 0, you can have, let's say 0, 1, 1, 0. This is identity matrices. We can have, in this case, you can see that the ones are diagonally actually presented, and also zeros are diagonally presented. So that is the actually identity matrices. And let's say we can have, and that should be, let's say we have 1, 0, 0. We should have 0, 1, 0. We should have 0, 0, actually 1. So this is what we call as the identity matrices. So in this case, the ones are diagonally presented. So that is a typical actually identity matrices. And how about, let's say, can have, how about 2 by, let's say 3 matrices, but it actually has to be identity. So in this case, we can have, we should have 2 columns. Should be 2 rows. We can have, let's say 0. That should be 0, 1, 0. Now let's start with actually, but we can have 0, 1, 0. And let's, we can have, that should be 0, 0, 1. So this is also part of what we call it as the identity matrices. So this is how you should have to understand about actually types of matrices. That is what we have it as the row matrices, should be row matrices. And we have what we call it as the column matrices. And we have a square matrices. And then we have the rectangular matrices. And we also have what it was as the zero matrices. And also we have what it was as the identity matrices. So this is how you should have to actually get it. So here's the question for you. So try to come up with actually at least actually 1 square matrices, rectangular matrices. In other words, try to come up with at least actually 1 of each type of the matrices. And I want to see that. Thank you.